Welcome, members and friends. Thank you for joining us tonight. My name is Leanna Orsua. I'm the membership manager at the Santa Barbara Museum of Natural History and Sea Center. We have a terrific presentation for you tonight on Chumash history, specifically the production and exchange of Chumash shell bead money. I'd like to introduce you to our Associate Curator of Anthropology, Barbier, who will begin with a demonstration on how shell bead money is made. Brian?
Good evening, thanks for joining us tonight. So what I have here in front of me are the types of tools and materials that you would expect to see in front of a shell bead maker on the coast of California for millennia. I have drills, the shells that were used, and the various tools to manufacture them. So the vast majority of beads that were made by coastal Californians and traded throughout California, the Great Basin, and even into the Southwest were made from the Olivella shell. This little gastropod you may have seen washed up on the beaches here in Santa Barbara, and they're prolific up and down the coast and on the Channel Islands. Now you could have just lopped the top off, like has sort of happened here naturally, and made a hole in the top and then stuck a string through the shell and strung up a series of them in the same way a puka shell necklace might be made. But the vast majority of beads, especially the ones that were strung and made into currency, were made out of the wall of the shell. And so ultimately you would end up with this very standardized string of evenly sized and shaped beads. This is the classic money bead, the callus bead, that was common during what we call the late period from about 900 years ago through Spanish contact. And so the first thing you would need to do is select a shell. And you might break it down and break it apart with a flake tool, like this chert flake here, using the edge to chip away. You might also use an antler. And then you also would have some type of anvil, or in this case I have a small tabular piece of sandstone, but we find very large anvils at the bead making sites on the Channel Islands. And of course you would need a drill, this one being a chert flake that's been broken from a larger piece of stone and then shaped into a drill bit. And so after you've selected your shell, the first step is breaking it down to get your bead blanks out of it. And so you'll start by breaking away the parts of the shell that you're not going to use and try to isolate the pieces that you do want to get out of it. And we know there's different approaches to how to do this based on some ethnographic descriptions and on the interviews of Chumash by J.P. Harrington. Particularly Fernando Labrado described his technique. And so you might get a large piece of wall out, and then you'll continue to maybe shape it further, chip it down, and get it into the shape of bead that you want to make. There we go. And you want to do all this rough work before you drill the hole, so that you don't waste your time if you just happen to break it in half. And then you'll do the finer finishing and grinding after you've drilled the hole. As you make dozens of these, you learn really quickly the order of steps to be efficient and not waste your efforts. Lots of little waste bits were broken off of the shell, and it was chipped down until you had maybe 1 or 2 bead blanks per shell. With the antler, I can get in here and get a little more of these fine corners off to make it more round without breaking big pieces off. And so once you have a bead of approximately the shape that you want to make, maybe like a large circular or oval bead, you would drill it. This type of chert drill was used up until the time of Spanish contact, when Chumash bead makers would then trade with the Spanish soldiers for their steel needles in their sewing kit, which they found much more efficient. And so you'll take a drill bit, and I usually like to sort of start a spot in the middle, kind of scratch a spot in this shiny smooth surface so that the drill bit stays put. Some bead anvils had depressions that the bead blank could be set into. I like to use the leather, it seems to grip the shell well. And so then you will get the drill in the center and then spin the drill. And this is the part that intuitively we like to think would be the most time-consuming portion of the bead-making process, but as you'll see a little bit later in my talk, this this can be one of the quicker stages of production. So this might take a few minutes though. I definitely am feeling it. Like my forearms are burning right now. I'm putting a lot of downward pressure on the spindle. And I'm using a technique to keep my hands floating here so that they don't keep going down. So I don't have to keep stopping and starting over. And so you kind of develop these efficiencies as you do this for several hundred hours, I imagine. When the drill goes through the bead blank, you might flip it over or maybe even pick it up, and you might just sort of clean up the hole on the other side where it's kind of rough and punch through the shell until you have a nice round hole. You'll take this bead and your abrading stone, and if you're finishing it individually, you would then just abrade off the high spots and then get it more rounded and even. And for certain bead types, this can really be the most time-consuming part. And so, in the end, what you end up with is a finished bead. But if you were going to make a string of very standardized beads, and you wanted to be somewhat efficient about it, and you wanted them all the same size, you'd probably string them in sets, as this is what is described ethnographically. You would string them in sets of maybe 30 or 50, and you would braid them and turn them and finish them together so that they all come out the same size and shape, and then do that repeatedly, 30 to 50 beads at a time, until you've made your bead necklace of, in some cases, what might be 400 or 500, or in a few cases, thousands of beads. Hello, everybody. Thanks for joining us. And before I begin my slideshow, I'd like to acknowledge that I am presenting this talk to you today from the traditional homelands of the Barbereño Chumash, who have stewarded this land for millennia and who continue to do so today. I'm grateful to be able to learn from both the past and present Chumash and other California Indian knowledge keepers. I look forward to supporting present and future Indigenous communities as they continue to practice and pass on their lifeways. So tonight I'm going to be talking about the production and use of shell beads in California, and my use of experimental archaeology to better understand the economics of production. I will get to the question, what does a bead cost, in terms of how I replicated the actual labor process. But I also want to give you first an overview of beads in general. And so contrary to the slide's title that I used to trick you all to get here, I'm actually going to talk about all kinds of shell beads used by California Indians and especially the Chumash, and that were made here primarily by the Chumash, especially out on the Channel Islands. So after I talk about beads, I'm going to talk a little bit about the production process and what kinds of things we can learn about bead making on the Channel Islands based on applying my experimental research to those remains that are left behind by the bead makers. And then I'll talk a little bit about my current research and data I'm collecting on bead exchange throughout California. So for millennia, the Chumash, and in fact, people from across North America, made beads from just about every suitable material that you could imagine, from large and small bones to different kinds of shapeable stone, and just about every different type of marine shell and even freshwater shell in some places, for a variety of uses. So what we have here on the left is what you may, if you're from this region, have seen before and heard about, the quintessential money bead that the Chumash used for hundreds of years, particularly during the late period. And these were what were in use at the time of Spanish contact. But laboriously shaped beads were used and made in this region for millennia before what has often been referred to as money beads. And they all have an exchange value. So even though we may not apply the word money to them, these beads have been traded far and wide across Western North America for millennia. And even before they were shaped
into more fine sized shapes from pieces of the shell. Whole shells were strung up and used for probably 9,000 years. One of the most common ways we think of beads being used traditionally is as adornment, similar to today. And in fact, throughout California and the Great Basin, shell beads were worn in a myriad of ways on all kinds of different types of clothing and ceremonial regalia, dance regalia, and attached to the hair, ends of the skirts, and embroidered onto all kinds of objects. And this is generally part of somebody's identity. It's part of how they're representing themselves at an event, and maybe they're displaying their social status in some cases, or indicating their role or position within society or within a ceremony. So there's a lot of meaning rolled into beads beyond just their economic value. But beads were glued onto and attached to, strung on, embroidered on lots of other objects. They weren't just worn as adornment. So here we have an example of this large couple-foot wide bathtub mortar with beads that had been applied to it on the rim and the sides. And this isn't something that somebody would use to prepare food every day. It's something that you would bring out on very special occasions, like a really big village-wide feast. And so some of these objects had beads added to them to sort of increase their visual sort of display and giving them this extra aesthetic. And so we see that commonly, that beads are glued on to other items. And in fact, beads were even glued onto other beads. So that's what I love. These are actually bone beads on the left. The bottom one with not just olivella beads, but also red abalone and mussel shell beads glued on to give it the color effect. And these beads were also glued onto many stone tube beads. And so this is an example, for instance, where these artifacts are a little less common. These are more rare. And it's believed that these may have been badges, political badges that just a few sort of elite individuals or with political status would have been able to wear in order to represent who they were in this role that they played politically. And so if we had shown you the video first of the demo I did outside earlier, the olivella shell that you see here is what most of these beads were made out of. Beads were made out of all kinds of other shells, but for thousands of years, this is the predominant shell used, but all different parts of the shell were used to some degree. The spiral top was used for beads. This inner callus portion is the part that's used for what are called the money beads or the cupped beads. And even the whole shell could be used. And what part of the shell was used or what form the bead took changed over time. So this is a seriation graph. This displays the relative frequency of different bead types during each time period. And so essentially what's happening here is the relative frequency of each bead type is by the row represented by the time period. So we can see here in what is middle period 4, that olivella disc, or what we also call saucer beads, were represented like 99% of the beads found. They're just a fraction of percent of these stone beads and these other ornaments found at the same time. We can see that even late in time, when many different types of shell were used, mussel, abalone, other gastropods, other little sea snails, and different parts of those shells were used to make different styles of beads. Even then, those were just a small fraction compared to what generally were the common currency, so to speak, even before they were money. And that's these sort of standard main olivella bead types. And we can see also by looking at it through time and seeing how it changes by time period, we see that styles changed abruptly sometimes or gradually. And so we know that the Chumash made a large amount of these beads. And one of the ways we know this is because of the significant amount of bead making evidence that's left behind on the Northern Channel Islands. The bead detritus from the late period, for instance, is massive and makes up a huge portion of the shell middens at these large coastal village sites. This picture here of all this shell debris is just the detritus from making beads from one thin level of an archaeological unit. And then here we have a bead anvil, we have some micro drill flakes, bead blanks ready to be drilled, the various bits of the shell left over, and then a string of these cupped beads. But even though much of the research on Chumash bead making and the bead economy is focused on the late period, there is evidence on the islands for bead making going back to the early period, so roughly 4,000 to 5,000 years ago, not just during this time when beads became really prolific and they were probably making hundreds of thousands of beads out on the islands. We have these smaller amounts, smaller bead lots, but consistent through time from this time forward. And so to get to the main question that my early research asked, how much time does it take to make a bead? Well, first I had to set up a replicative process that was as true to the traditional methods as possible. So I had to acquire the traditional materials that were used. I had to figure out how to replicate the process that people were using and not just make up a new process that wasn't how they were doing it. And then, of course, I'm looking at several bead types over time. And so I had to look at changes in the methods that people might have used to make beads over time. And then finally, to start collecting data, I had first to become proficient and get past a learning curve and really get to a point where I felt like I could sort of go as fast and as skillfully as it could get. So the first place to get information about this, where we archaeologists start often, is the ethnographic record. And there's great descriptions of how Fernando Labrado made beads himself through his interview with being interviewed by J.P. Harrington. And we can see in what he describes in these quotes here about how he breaks the olivella shell and sort of gets to the bead blank and then drills the hole. We actually see all of this in the archaeological record, but I also noticed as going through sites that had beads across a long period of time that the methods people use changed over time. And so then I turned to looking directly at the bead making detritus and basically created a typology here of the different sections of the shell that were left behind. And even within the debris that's left behind, we find abandoned bead blanks and things that help us tell what type of bead was being made at that time. And you can see that in the record going through time, what I have outlined here, for instance, are a couple diagnostic types that you really only see in the early period and the late period. But these fragments of the shell are relatively absent in the middle period, suggesting these shifts in how people made beads. And so I worked to make sure that when I split the shells down and made bead blanks of a particular type, that my detritus ended up matching and coming out the same as what was common in the time period that I was replicating. And so to get to the answer of that first big question of how long it takes, these are the total times and broken down by stage for the three major bead types from early, middle, and late period. And so one thing that a lot of people have heard about is the sort of the development of currency among the Chumash in the late period, and that these cupped beads, they're really thick and they took a really long time to make. And it was surprising to learn in my experiment that they didn't take, say, an hour per bead, like some people had suggested. In fact, they didn't even take twice as long as the thinner saucer beads that were made in the time period before. So this was a little surprising. It was also counterintuitive to find out that the non-drilling steps in the production process took more time overall than drilling. I think a lot of people intuitively would think that the drilling process, since it involves this more technical process and complex tool, would be the longer portion of time. And of course, because there's also a lot of investment in specialized drill bits by the Chumash out on the islands. And so certainly, you would want to economize every step of the production sequence, but surprisingly, collectively, drilling didn't take the total longest amount of time. That was counter to my expectations. But drilling did take a long time, particularly for the callus beads, these money beads in the late period that come from that inner portion of the shell that's about 2 meters thick versus almost 1 meter thick wall on the rest of the shell that had previously been used. And so these took maybe a half an hour to make or so, but you find deposits of these beads in sites throughout California, really, where you have hundreds or thousands of them in one site or location. And so this is important then to be able to take these times now, and now we can look at across the landscape, we can look at different regions, we can compare across time periods even, as I do here, just how costs have changed through time, how investment in bead making changed through time, or we can look at the amount of finished beads themselves. So if we were to look at, say, how many hours it took to make 100 beads and how that changed through time as the bead types changed, we can see that there's a general trend upwards in among the Chumash, at least in this region of California, peaking in the late period with the callus beads, or the so-called money bead. But I've included some preliminary data here that I still need to flesh out and collect more data on. And that is the beads that were made after Spanish contact and moving in and through the mission period. These become far more expedient. Ultimately, by the end of the middle period, the beads were really not finished on the edges at all, were not ground down, which of course would have saved a lot of time. So the ability to make a lot of beads expediently becomes a new motivator in the mission period. And so there's a lot of research done about that. I could do a whole nother talk about that. But what else can we learn through application besides how long does it take to make a bead? I wanted to kind of look also at the changes in levels of production intensity, both out on the islands, elsewhere on the mainland, through time. There's been a lot of previous research about bead production on the islands based on all this debris left behind and looking at the different time periods that are deposited in these sites. But I had a hunch that the different types of beads would leave behind a different amount of detritus for each type. And then if we could convert that, then know how much detritus left behind equals how many beads, that would give us a more direct method for assessing bead production, because of course we're interested in how many beads were made per period of time at a site, not so much how much waste was left behind at a site. And so it turns out the beads did leave behind significantly different amounts of detritus, particularly nearly 3 times as much debris is left behind when making these money beads. And this is largely because using that inner callus of the shell, only one bead type really can be made. I mean, one bead can be made from the shell. Whereas when you're using the outer wall of the shell, the whole shell, you might be able to get 2 or 3 bead blanks from each shell. And so you're using up and sending away more of the shell as finished beads. So this is helpful because previous studies, which were really groundbreaking and great for showing how much bead production changed, especially as it increased in the late period, they were only comparing the actual detritus itself. And now we can actually sort of apply this as a conversion factor to say, well, but how many beads were being made per, say, cubic meter of material on the sites? And so again, previous studies suggested that in the late period, with the advent of money beads, that bead production increased by maybe up to 1,000% over the middle period saucer beads that were made before. And that's similar to what I see in these 2 village sites that I studied across time from Santa Cruz Island. We do see this huge increase over the middle period. But when converted to beads, that huge increase that was, let's go back really quick, especially compared to this time period, and I'll get to this discrepancy in a minute, what looked like maybe a 500 or even 3,000% increase is maybe really only a doubling of bead production rates by the late period. And this is by now converting the detritus based on the bead type primarily made at that time, so that you know, and applying that grams of detritus left behind conversion factor. So we're talking apples to apples now when we talk about the wall beads of the earlier middle period versus the callus beads of the late period. And so I can also then take the time data that I shared earlier, my initial research, and apply that to the number of beads. We can then convert that to time. And we can look at how the amount of time investment changed, since it does take more time to make those late period callus beads. And so it is still a pretty significant increase, of maybe 3 times as much labor invested in the late period at these villages than earlier. But what about this huge decrease? I think in the end, after looking at this data, this is what became more interesting to me, is that this huge 5-fold decrease in bead production between the earlier middle period And what's deceptive on this graph, this briefer late middle period, that's a little bit shorter span of time than either of the two periods before or after it. And what we do know is that there were environmental stresses for much of the late middle period. We have the medieval climatic anomaly, which was a climate change of the day, where conditions became hotter and drier. It's thought that there was a big population decrease on the islands, maybe due to a lack of potable water, and maybe some decrease in certain food types that they use. And we see then that sites at this time are less frequent. They don't appear to be occupied sort of year round. They seem to be shorter occupations. We see a decrease in the use of shellfish, which is one of the primary food types used, throughout time on the islands. And we see an increased diversification of plant foods. And that often suggests to us that people are having to move to more and more types of foods or plant foods that might take more time to process or gather because there's less availability of the primary staples that they've relied on before that. We also know that in the late period, at this time that bead production flourishes on the islands, we know that there is this island-wide population rebound from this period of stress and infilling. And we see people especially moving into more consolidated, bigger, denser village sites along the coastline, which happens to be where we find this abundance of bead-making evidence. And so it's quite possible that the interesting thing is not so much how much bead production took off in the late period, but instead this late middle period time of stress. But also then that when looking at the broader view and looking across time, maybe even into the early period, that per capita investment, like how much time was the average person or bead maker spending making beads in their daily tasks and rounds, may not have changed that drastically through time, but may have been a fairly consistent activity for the island residents for millennia. And so I'm going to go ahead and move on to what I'm currently working on. I am looking at the exchange economy of beads. So shifting from the production sites and now looking at the beads themselves, where they end up across the landscape, both within the Chumash region, and also I'm looking at comparisons with the Chumash and their neighbors and farther up north in Central California. And so one of the areas that I'm looking at is how, using this knowledge now about how there's production signatures, there's actually sort of like forensics, right? There's traits on the beads themselves that became apparent to me as I learned to replicate them and consistently copy them. I realized that there's probably some differences in production traditions between different communities or groups who are bead makers, and they're going to pass down those practices. And those practices are going to leave evidence behind on the beads themselves. So I'm doing a lot of fine-grained measuring and analysis of beads from throughout the Chumash region and from Central California, looking at differences in their size and their roundness and how centered the whole is, how standardized they appear, how the edges are finished. And then basically, once I've collected enough of this data from across the landscape, looking to see if there's trends that are different geographically, or if the variation is really widespread and doesn't really indicate that beads were made, the same types of beads were made differently by different groups of people in different places. This goes to a long question about, did the beads at certain times that you see across California really all originate in the Chumash region, where we see all of this bead making evidence that no evidence elsewhere on the mainland of California ever quite equals. And so just for a preliminary example here, I did some early data analysis just to look for some trends. And here's a comparison of the variance in bead length. So this would be the vertical diameter, top to bottom of a round bead, and between a site in Alameda and a site, or in Alameda County, and a site here on the mainland coast of Santa Barbara. And so this gives me an idea then that this could be a fruitful comparison, but of course, could be that the beads up in Alameda are just a smaller group of beads. And so it really will take a multivariate approach, a comparison of the whole size, the roundness, the centeredness of the whole, the type of edge finish, and looking at these using multivariate analysis to get at this question. And so that's where I'm heading with the statistics as soon as I've completed gathering that data. Another data collection process that I'm in the middle of right now, getting closer to wrap up, is collecting stable isotope samples. And so stable isotope sourcing analysis is a way that we can actually tell where on the landscape that the shell the beads were made out of originated. Different coastal environments, due to sea surface temperature or even coastal upwelling, they leave different ratios of these oxygen and carbon isotopes in the shell. And so using this cutting edge carbide burr here, which is my cutting edge method, I actually take samples from the beads themselves, several samples per bead. And once we get the results back, we can actually look at, I'll just show you really quick. This is what it looks like to sample the beads. We take them in the individual growth lines so that we can control for seasonality, effects like El Nino years. And we just have to take this tiniest little sample, micrograms of powderized shell from each of these samples in order to get results, which is really handy. So we do very minimal damage to the bead. And then we can get like a signature of what the sort of the isotopic signature was where that shell originated, with the assumption that bead makers wouldn't probably trade for olivella beads, which are abundant near where they live, that came from hundreds of miles away. And right now, the most significant difference we can identify is between north and south of Point Conception as a sort of breaking point. You can empirically see other breaking points within those regions, say north or south of Point Conception, but it's hard to pinpoint where exactly that's from. But you can take a look at a group of beads, isotope signatures, and another group of beads, isotope signatures. And I'll show you the graph now. As they graph out, you can see some clear breaks. You can see beads that came from waters that maybe are enriched with fresh water, like in an estuary. And so here's a colleague of mine, Greg Burns's results from looking at saucers in Central California, which I'm going to be heavily comparing to with my results because I'm focusing my data collection now mostly on the Santa Barbara and surrounding regions. But here what we have are this red ellipse is the expected values for Central California sourced shell. And the blue ellipse is the expected values for Southern California or south of Point Conception source shell. And so there is this problem area where beads fall in the unknown middle, where it's just too, the data overlaps too much to say for sure which area they came from. But as we see here, Greg actually found that some beads appeared to reliably come from Southern California, even though they were found, for instance, in Alameda County or Santa Clara County, and that some other beads were clearly made in Central California. And so part of the reason I'm focusing on this, comparing Chumash, the Chumash region and their neighbors to Central California, is this has long been a question among bead researchers in California, particularly at this time in the early middle period, when it so happens that throughout these both of these regions, everybody was using saucer beads. And then abruptly, around 13 to 1500 years ago, people in Central California just stopped using saucer beads, even though the Chumash continued to use and make them, and they were the most abundant bead in this region where we are today for hundreds of more years. And then going forward into the late period, the Central California bead types took their own stylistic trajectory, and some beads were still imported into Central California, but not nearly to the numbers of the beads that they shifted to using up there. And so I'm focusing on this time when I can actually get at this broader interregional exchange occurrence and find out, unlike where it's easy to see that beads went from the Santa Barbara coast inland to the desert, when we find them there, we know, for instance, and we can tell often by the styles, that beads in the desert didn't come from the desert since there are no marine shells there. So that east-west pattern of exchange has been, long visible to archaeologists, but many people have wondered just why the beads are the same in Central and Southern California. You could assume they're all made by the same makers, or it could be that there was a broader stylistic convergence that people believed at that time. This is what beads are supposed to look like. These are, and people are trading with their common neighbors, people in the transitional zones who are possibly accessing beads from both directions. And so that is the talk portion of my talk for now. So the first question I see is, who owns the beads? Community or maker? Well, so we do see that there's a vast amount of bead waste on the Channel Islands, where we know beads were made, for each time period of the hundreds of thousands or millions of beads in these time periods, but we don't find that many beads on the islands. So they're definitely being made for export. And then among the coastal Chumash groups, we have ethnographic descriptions of how people use these beads as currency, traded them for specific amounts of other goods. They even had tattoos, particularly the chiefs would have tattoos on their arm or wrist, and they would be able to wrap the bead necklaces or strings around their hand and then measure them to the tattoo to know how much of a string of bead that they had, to sort of give it a unit of measure. But these beads were traded inland as far, in some cases, as the desert Southwest in New Mexico and Arizona, and into Utah and even Colorado in very small amounts. And so the beads were owned, I think, by the people who traded for them, who got them from the person in the line ahead of them. There's some question as to whether or not the bead makers on the islands were sort of being driven to produce so many beads by the chiefs on the islands. And there's still much disagreement in the research community about exactly what that political situation looked like. I tend to fall on the side of, bead makers responding to the immense demand for them, and that there was an ability, there was so many of the Chumash plank canoes available on the channel to get them to the mainland and get them out. And then, and then we see them in large numbers going very far inland. There's beads recovered in the thousands in the Mojave Desert and on the east side of the Sierra Nevada. Production lines used. So that's a tricky one to get at archaeologically. Some of the ethno-historic accounts we have, descriptions, for instance, in the missions of bead makers, is that there were particular people sitting and making the beads, and it appears that they were doing the whole process and it wasn't a segmented production line. But I haven't published on this yet, but I recently analyzed a whole bunch of bead detritus from Point Ana Nuevo in San Mateo County, just south of San Francisco, or just north of Santa Cruz. This is a late period site that it's the only other place I've seen bead making evidence that rivals the amount of detritus you see on the Channel Islands. And of the large Rubbermaid of all that was sampled from this archaeological unit, there's not one drilled piece of shell, but they're all clearly being made into the appropriate sort of blank. And so there they had a segmented production system where the beads were broken down at the coast, and then the usable parts were brought inland, probably to the Bay Area, to the bigger villages. Did all ages and sexes make beads, or just certain people in the family? So again, we have ethnohistoric and ethnographic evidence of both men and women making beads. And Jean Arnold and a colleague recently published a paper, not recently, maybe 5 or 6 years ago, where they were looking at some evidence of maybe some learning, or maybe child bead makers learning how to drill the beads, because you'll see these bead blanks that have 2 holes, maybe 3 starting to be drilled, but they're never finished. We don't ever see finished artifacts that look quite like that. And so probably people got involved young. Most Native Californian communities, you learn by sort of doing and participating, watching, and getting involved. And it doesn't appear that there was any sort of restriction in who was allowed to make beads. But we can't really answer those questions when you go back several thousand years. That's really hard to get at from just looking at the evidence that we have in the archaeological sites. And Deborah asks, when the Chumash glued shells, what did they use for glue? Well, here, especially on the coast, what we most commonly see is asphaltum. So for those of you who have walked barefoot on the Santa Barbara coast, I think you know what asphaltum is, or beach tar. And we have some major tar seeps here on the mainland coast. There's a big one near near Goleta Beach. There's some tar seeps coming out of the cliffs all along the Gaviota coast. And there were tar seeps on the edges of the islands. There's a big tar seep on the west end of Santa Cruz Island. And then the tar also, the float tar, as they call it, washed up on the beaches all over the place. And so that's what the people who had access to it used, particularly in coastal California, but even inland, there's tar seeps in the hills just west of Bakersfield. There's some big tar seeps that were used in pre-contact times. But people also used pine pitch and other things as a glue. And there's lots of different formulas different people had for glue. What we see on most of these artifacts and ones that I showed in the slides is probably mostly asphaltum. And then maybe in some cases, pine pitch is mixed with it to change its pliability or its flexibility. I've found personally, especially with my old asphaltum, that adding pine pitch can kind of rejuvenate it and make it work as a better glue. So Tony asked a similar question about the glue used. Same with the drill to the shaft. You may have noticed that the drill bit that I showed in the video looked a little blackened on the end of the stick where the drill bit was inserted. And I originally glued them in for the experiment with asphaltum and pine pitch. And that broke a lot. I didn't have sinew, which would have tied that drill bit on maybe to make it more sturdy and stable. I didn't have at the time early on. And then I realized I wasn't really experimenting with glues. And that was an important part of my research question. So I reattached all my drill bits with hot glue. But that's essentially what the Chumash were doing. They were having to heat up the asphaltum or the pine pitch, and they used it just like we use hot glue today. We find the mixing dishes and the applicator tools with the pitch or the asphaltum on the ends of it, indicating. And sometimes we find all the other parts and pieces of the different sort of craft production happening, whether it be the asphaltum lined water bottles that were used, to hold water, that they line the inside with pitch to make them waterproof. And so I'm not sure how often, if all of the asphaltum gluing apparatus has been found directly with the bead production at the bead production sites. That would be an interesting thing to see. Excuse me. So we're getting the glue question. Yeah, so and you guys can go out and collect this glue. I recommend getting more flexible glue, and this is worth just trying out sometime since and it is kind of an interesting thing. So you can go down to the beach and get some of the softer balls of tar that wash up and maybe rinse the sand off of them. And I just use a little cheap metal dish that I didn't mind ruining that I just heat up over a flame. And you can collect pine pitch, especially where the beetles have gotten into it. You can collect the pine pitch and take it right off the trunk of a big pine tree and just pick the bits of bark out of it. And you can put that right in the dish with the asphaltum and experiment with what kind of glue you like. I've read some formulas from other parts of North America where people talk about putting other additives like the white ash from a fire pit, the charcoal, or even ground up bird egg, and that these lend different properties to the glue to make them more flexible or to make them more resistant to coming loose when they get hot. And Nancy asked, do you know if Chumash beads were found in the Emeryville shell mounds in Alameda County? Approximately 20 years ago, a developer did pave over the area. So if anyone's been to IKEA in Emeryville, then you've stood on the Emeryville shell mound on Shell Mound Way. And there were tens of thousands of beads found over time in the Emeryville shell mound. And I believe Greg Burns may have sampled a very small number from that site, or at least one of the adjacent shell mound sites, maybe the Berkeley shell mound. I would have to double check on that. And I'm not sure actually that he didn't necessarily always have definitive evidence that the beads came from the Chumash region or from Central California, because a lot really did fall in that ambiguous overlap area on the graph. And that may have been the case for Emeryville, but that'll be something that I'm going to try to look into in future research. It's going to be a bigger question than I can incorporate into my current project. But definitely the region, the Alameda County region, there are beads in that area that have a signature indicating that they came from Southern California. And then we can infer that likely means they came from the Chumash region, because we just don't see a similar amount of bead production happening outside the Chumash region down here. We do, but just it's just exponentially more bead production evidence here in the Chumash region. So wrapping the beads around the hand for currency. So let me see, that is An anonymous attendee wants to know how the beads wrap around. I don't know the exact technique, but I have a string of, these are actually clammed. So this is what people shifted to making in the late period, these big clamshell disc beads. They don't have olivella beads easily accessible, but here's an olivella shell. Just to give you an idea that the clam disc beads are much bigger than the olivella beads. And so they had different techniques in different areas, but I believe it was wrapped around the hand and then maybe up to some point on the wrist where the tattoo, and it's been a while since I read about this. Hopefully maybe somebody, I know I have attendees who might know this answer, who maybe can comment in the chat. But the groups in far northern California who didn't use olivella, but who used dentalium shells, they did something very similar. And they would actually run their string of dentalium around the elbow. And then I believe the tattoo was on the upper forearm somewhere. And they had different tattoos for different types of strings of beads because there were more valuable big dentalium shells strung together and then less valuable short dentalium shells. And very similar to olivella, but we're essentially talking about northwestern Humboldt County and Del Norte County in the far corner of California. They use shells very similarly. They just didn't use olivella shells there, at least not to a appreciable degree like the rest of California did. Sorry, excuse me. Christina says, I was reading that many of them traded daily. Do you know how long it took to travel within the Santa Barbara County on canoe from maybe Guadalupe to the Channel Island? Well, I don't think anyone would have probably traveled from the groups who lived around Guadalupe. The Obispeño Chumash and the folks up north didn't use the plank canoe. Generally, the plank canoe is only found south of Point Conception, so along the south-facing Santa Barbara coast, out on the islands. And then the canoes were traded down and maybe also made by the Tongva on the southern Channel Islands, which would be like Catalina Island, San Clemente Islands, and the ones that you would see off the coast of Long Beach and even from San Diego. So the channel is a great place to get out and get 10 or 20 miles from the shore. But if you've ever looked out on the coastline near Morro Bay and elsewhere on a windy afternoon, that might not have been a great place to use the plank canoe. So at least when the earliest Spanish explorers got here, they weren't using it. But it takes quite a few hours to paddle across the channel to get to the islands. And then if the average person, not accounting for hills and mountains to climb, maybe can walk 20 miles a day. So again, if you're going to see Guadalupe, that's far north is Guadalupe. I mean, you're probably several days away. So what probably more likely happens is you travel to your nearest neighbors, and things were traded on often as they were passed hand to hand. And one person didn't always carry them on down the line to where we ended up finding them today, where they were deposited. Yeah, so I know that Chumash descendants today have revived the practice of crossing the channel in Chumash plank canoes. They've made replica canoes made with the traditional materials, and they paddle out to Santa Cruz Island, and they've done this a number of years. And they leave very early in the morning so they can beat the wind and avoid getting caught in the late afternoon winds that are common in the channel that those of us who are sailors love. So we believe that they may have even left really early in the morning before the sun came up to really get the calmest water, because paddling over swells also just increases the length or the distance that you have to travel. When did bead making end and why? Well, beads were made through the mission period, and some people were still making beads after the mission period in terms of what we find archaeologically. But Chumash descendants are still making beads today. I've spoken to several Chumash people, Ventureño and Barbereño Chumash, who have made beads. And we've discussed our different tricks of the trade for how we each do it. And so people are still applying beads to their regalia and their ceremonial objects and items and trading them among their friends and family. And Linda Yamani, who's an Ohlone person, so from the Bay Area, kind of from the East Bay and near the Emeryville Shell Mound, the Ohlone lost direct record of a lot of the practices prior to the mission period. The mission system was really hard on the Ohlone people. And so Linda actually studied a lot of things in the museums and figured out how to make Olivella shell beads. And she's also revitalized Ohlone basket weaving. And she covers the outside of some of her baskets with Olivella beads that she makes herself. And it turns out, even being self-taught, she goes through a lot of the same processes that I ended up replicating in my study. What was the string made from? So the string could have been made from a whole variety of plants. So the cordage, as we call it, which is usually twined plant fibers. Here along the coast, among the Chumash, they often use juncus. So we have a very long rush, Juncus textilis, which was used in basketry. It's one of the most common basketry materials among the Chumash. And so that would have been a common string type. In fact, that was the string they were strung on in short lengths for the mass grinding. But you could have used dogbane, cottonwood inner bark from the cottonwood tree, milkweed, yucca, even the yucca that we have here growing in the hills. You can process the leaves and get the fibers out of the middle of the leaf. And that yucca actually makes really strong string. But we don't always find the string. You know, we rarely find the string archaeologically. We have strong examples from dry cave settings and places where it preserves. And a lot of those are inland. So I think there's a whole variety of plant materials. And I haven't really cataloged yet, like what all the different, for instance, in our collections here, I'm not sure how many different material types are represented. Sometimes it's hard for us to tell. We don't necessarily want to do anything destructive to figure it out. And so, but my best guess from a lot of what I've seen is juncus and dogbane probably is the most common that I've seen. Karen asks, so the value of shell beads. Well, so I can't put that into modern money terms, but the Chumash conserved sort of a set value for different staples and trade items in amount of shell beads. So a certain length of string of shell beads would be required to buy a bushel of acorns. It'd take more beads to buy a processed bushel of acorns. Even things like deer skins or other objects, they had a known value, and this value was apparently conserved, and that different groups often shared these values to they're in ethnohistoric accounts and to some of the early ethnographers, that it appears that the values were fairly standard. But how to translate that today is hard to say, but I can just say that a big string of beads that probably has encapsulated in it dozens or maybe close to hundreds of hours is how much labor is in that string of beads that then might buy you, I don't know, 20 or 30 pounds of some food staple. So the beads had a very high investment, and that's why they probably were able to carry their value between group to group and maintain their value in trade so that they weren't just like an end product themselves. It was important to be able to trade them on and pass them on for other materials. And how big, what were the dimensions of the shell mounds? Shell mounds vary widely in size, and on the Channel Islands, they can range in size from just being a few meters, let's say maybe 5 to 10 meters, or what would maybe be 15, 20, 30 feet wide, and maybe a meter deep. But some of the largest shell mounds, like on Santa Cruz Island, the largest shell mound there is about 3 meters deep. So 9, 10 feet deep at the middle. And it's really extensive. It's more than a football field, maybe 2 football fields long for the mound proper. And again, and this was at a village site that probably was bigger than even the mound itself to some degree. There's evidence of how people lived on the edges of the mound and off the edge of the mound and used different areas of it. But I'd say on average, the shell mounds might be the size that you could fit a half a dozen traditional houses on and around. Several shell mounds along the west coast of Santa Cruz that are all relatively the same size, I'm guessing are maybe about 20 meters in diameter. And then we find much smaller shell deposits that you wouldn't necessarily call a mound, but we do find shell middens that are kind of flatter and a little bit more diffuse that might also measure 20, 30 meters, so 30 to 100 feet. And then we have shell mounds. I'm now thinking we have shell mounds on San Miguel Island that stretch for hundreds of meters. They're actually elongated, maybe because of the wind patterns out there. And so you have shell mounds there that are dozens of meters wide by hundreds of meters long. Okay, and then to go back to the wrapping the shell beads around your wrist and how that worked with accounting for the amount of shell beads or the value of that string of beads. The tattoo was put on the arm of certain individuals among the Chumash, primarily like the chiefs. And that would be so that this technique they have of how they wrapped it or how many times they wrapped it, and then it would reach the tattoo would be the sort of the end of the measurement. So you would maybe go around your hand a certain number of times and then pull the string down to the mark. And so these strings of beads were, they're modifiable. You can take them apart, you can combine them together. So you find beads that are deposited in the numbers of, let's say, 40 or 80 or 100 deposited in one place, or say buried with one individual. And then you find people with tens of thousands of beads. And you see variation. The tens of thousands of beads aren't all perfectly the same. And so probably they were combined together. And so as these strings were traded, people probably had ways of maybe you could say cutting them up, or dividing them up, because they don't want to overpay. They gotta make some change. Say, that's only a half a bushel acorns. I'm just going to give you a half a string of bead today. So what's the most amount of beads found at one site? And for Olivella beads, the most beads were found at Alameda 413, which is a site in the Livermore Valley. So Livermore is in the East Bay, sort of just inland of Hayward and Oakland by maybe about another 20 miles. And it's just over the hill from the Central Valley, which would have been one of the primary trade routes up and down from Southern and Central California. And one individual there was buried with over 28,000 Olivella saucer beads in the middle period. So this is before money beads. And those include some beads that were sampled by Greg Burns for isotopic sourcing. And it looks like those may have come from both Central and Southern California. And that would have been a great place there at Livermore. Would have been considered sort of like a hub, sort of the gateway into the Bay Area from the Central Valley for some people. And Genevieve asked, did the Chumash eat the Olivella snails or just use empty shells? As far as I know, for the Chumash, there's no real strong evidence that they ate the snails. They are technically edible. They're not poisonous or toxic or anything like that, at least most of the year. And there is some evidence. I've talked to an Esalen woman who said that she did read about her people or the Southern Ohlone. So this would be from the Monterey, the Big Sur, Monterey, Santa Cruz area, that she had read that people did actually eat the snails. And people on the coast of California ate other types of gastropod snails. So the black turban snail, if you've ever seen this more short, squat, black snail shell on the beach, that's maybe as round as a $50 sometimes, usually as round as a quarter. Those were eaten by different people on the coast at different times. Near the coast of Santa Cruz, there were time periods where people ate a lot of those. They must have become important or a delicacy.
Brian, so we're coming near the end here. Would you want to maybe answer one more question and then we'll wrap it up?
Perfect. Okay, so, well, one more question here from Nancy is, where in Livermore is the burial? Well, the burial has been reburied. And because of the sensitivity of archaeological sites, if I knew exactly where it was, I actually couldn't share that on this presentation. We tend to keep the site locations confidential so that looters don't go and try to dig up more of the material. But generally, I think it was outside. It wasn't in the city of Livermore. I think it was like farther out in the valley, maybe towards Vasco Road, but I couldn't pinpoint more than that. I've only seen it on very small scale maps. Yeah, so yeah, thanks for those questions. And I'll turn it over to Leanna. She has one more message for you guys.
Thank you for joining us tonight. We hope you enjoyed our presentation. We have 2 more wonderful conversations with our museum curators coming up this spring. Reserve your space for our May 20th presentation, Digging Deep into Dinosaur Evolution. And on June 10th, Scallops, Oysters, and Mussels. Oh my! I look forward to seeing you on your next museum visit. Thank you for supporting us. We'll see you here soon.